Good morning, good afternoon, and good evening, everyone. My name is Nate. I also go by Hockey Boy Nate. Today, we are going to be discussing a severe weather outbreak with the potential for it to become a tornado outbreak in the mid part of this week across the Central Plains, as well as a severe weather outbreak that will most likely ensue in the Northeast, as well as in parts of Quebec. So if you guys live in those areas, I highly advise you all to monitor this very, very carefully. And if you guys are new to my channel, please be sure to like the video, subscribe if you are new, turn on notifications, share this with friends and family and on social media. Also follow me on social medias. In the description down below, there's also my Discord server where I hang out most of the day. If you have any questions and stuff like that, feel free to ask me on there. I also have timestamps in the video here. This is basically there to help you all go through specific parts of the video that you may want to see. So I have these first 3 slides here that'll tell you what I'm going to be talking about today. And if you live in these areas, I highly advise that you all go to that specific time frame. So this is the day 1 outlook here for Tuesday, May 25th. This is the day 2 outlook here for Wednesday, May 26th. This is the day 3 outlook for Thursday, May 27th. But let us talk about the day 1 outlook here for Tuesday, May 25th. We have a massive marginal risk here that goes from the Midwest all the way down to the Southern Plains. The marginal is the dark green here. That is a 1 out of 5 on the severe weather scale here. And then we also have our 2 out of 5 on the severe weather scale here within these yellows. That is also known as a slight risk. There's also a little mini marginal risk here in upstate New York as well as northern Pennsylvania. So if you live over there, you also have the chance for some severe weather within your general vicinity. This bright green here is just a general thunderstorm risk. So you have a very, very, very small chance of severe weather, but it'll be more or less kind of just a passing rain shower. Now, if we get into the probabilities here for each parameter, this is the hail outlook here. 5% is indicated in the brown, a 15% is indicated in the yellows. So whatever probability you have, that is your chance of seeing 1-inch sized hail or larger within a 25-mile radius. You also have a hatched risk right here for significant severe weather. And so what that means for hail is that you guys have a 10% chance or greater of seeing 2-inch sized hail or larger within a 25-mile radius. So definitely something to where if you live in this part of Texas near Midland, you're going to want to get into a sturdy structure and definitely bring in any things that are outdoors that might be able to get broken of any sort of shape or fashion, like cars. Bring it into your garage or some sort of sturdy structure. That way, no dents or cracks in windshields. That's kind of a nuisance. Even, you know, speaking off of experience, I've had hail on all sorts of cars and vehicles, and that's a hassle to go through with the insurance agency. You also have a 5% here in the Northeast, so you do have that chance for hail present there. If we go into the wind outlook here, we're backing up a bit. Actually, the wind and hail are almost identical here. That's kind of the interesting thing. Actually, you know what? It's not identical. This graphic is wrong, more or less, but it's almost identical. So if you live in these areas, 15% is indicated here as well as our 5%. So whatever probability you have, that is your chance of seeing 58 mile per hour wind gusts or larger within a 25-mile radius. And then you also have your significant risk for wind down here. That is indicated that you guys could see 74 mile per hour wind gusts within a 25-mile radius. So definitely something to watch out for there. And then you also have your 2% chance for tornadoes. And this was recently updated to where you have a massive expansive risk for tornadoes here, basically across one border to another. And so if you live within this 2%, you definitely have an expansive risk for tornadoes. A small chance here, it's but a non-zero chance for weather. I probably won't be live streaming this here today. I will most certainly be live streaming tomorrow. Whether I will storm chase or not, you know, that's to be determined. But massive risk for tornadoes here, but it is a small chance in a general area. Let's get into the timings here. This is the simulated reflectivity from the HRRR model. We're using this model here because I personally believe this is the most likely outcome to happen. It doesn't have any limiting factors here, and so it's more than likely the model that I would use. If you want to keep in touch with the time, look up at the top here. This has all the information you may need. It's going to be a common reoccurrence, so If you're here throughout the entire video, then feel free to continue to watch up there and see what all we are looking at. But by 11 a.m. Central Daylight Time, we have some scattered showers here in Oklahoma and Texas. That's kind of what we've been seeing here for the majority of the week, how it's always started more or less with showers in Oklahoma and Arkansas. There is a marginal risk for this general vicinity as well. And so this right here, you can see some gusty winds within your general vicinity, maybe even some spotty hail. But once you start to get into the latter stages of the evening, that's when you can start to see some of your bands of showers that can really start to pop off from Green Bay all the way down to a bit of Des Moines, all the way down to Kansas City, even further down to Woodward, Oklahoma, over to Amarillo, and then all the way down to Odessa, Texas. That general vicinity could really start to see some thunderstorms overnight. And as this continues to move on through towards the midnight hours, the potential for some severe weather exists even still, maybe even to places like Oklahoma. But on the recent models, these storms have started to kind of deteriorate a little bit, but still something to watch out for as this continues to move on through. Dew points. We look at this to see what the moisture is in the atmosphere. You typically want over 60 degrees for thunderstorms in general, specifically severe thunderstorms. And we have that. All these yellows here are 60-degree dew points and above. We have a lot of these yellows, even oranges, that indicate 70-degree dew points. And so we have a lot of moisture here in the at the surface for thunderstorms to continue to feed off of. And so that right there checks off in our severe weather checklist. Now let's take a look at our convective available potential energy. This is the measure of warm air rising and cold air sinking in the atmosphere. The displacement between the two can actually indicate energy for thunderstorms to be able to form or sustain. And so you would want to look for about 2,000 joules per kilogram, which joules per kilogram is just a unit similar to how Fahrenheit is for temperature. Joules per kilogram is a measure for energy. And so you would typically want over 2,000 joules per kilogram CAPE in order to get strong severe storms, more or less. And everywhere in the yellow is 2,000 joules per kilogram and above. So these reds indicate 3,000, purples indicate 4,000. Some of these whites right within the purples and even discrete areas near Childress, that also indicates 5,000 joules per kilogram. So you have quite a bit of CAPE here today, and definitely a plethora amount of energy for thunderstorms to form or sustain. But this alone, you need more than just energy and moisture in order to fire off thunderstorms. You also need wind shear, and what we're going to be looking at next is our 500 millibar wind shear, or winds 1 kilometer above ground level. And so what we're looking for here is we're looking for the low level jet. This is the typical height that we would find it, and we have a little bit out in front of the showers. But if you remember how our marginal was situated, it was kind of right within here. So it's not exactly a all too good low-level jet, besides if you're up here into the Mississippi River Valley, into the Midwest, as well as here in western portions of Texas. But areas near Kansas, Nebraska, Iowa, Missouri, not exactly your day for severe weather. That will be the next day, more or less. Your 700 millibar winds, this is your mid-level jet, or 3 kilometer above ground level winds, and it's not too bad. Kansas definitely has some decent wind shear here. You can indicate that these greens are not too bad, and in upwards of 20 to 25 knots, maybe even higher in some spots with some of the yellows. But we do have some decent wind shear here in Kansas and Oklahoma, so that's the reason why some storms do form out there as well. And so that kind of fills in the gaps as to your severe weather risk. All right, let's talk about our day 2 convective outlook here. This is for Wednesday, May 26th. We have a massive risk for severe weather, I'll say that much. Your dark green right here is a 1 out of 5 in the severe weather scale, other known as a marginal risk. We have our yellow over here, which is a slight risk. That is a 2 out of 5 on the severe weather scale. And then we also have an orange risk right here. I said I would not be surprised if we saw an enhanced risk, which is a 3 out of 5 on a severe weather scale. I also wouldn't be surprised if we saw a red or a moderate risk, a 4 out of 5 on either here today or not today, for the Wednesday or for Thursday. It's still something to watch out for as time continues to progress. And as I said, I'll continue to update you all in the mornings as much as possible. But I would not be surprised if we saw an upgrade within all of that. But we have a pretty expansive risk here in the Central Plains, even into the Southern Plains, with a classic dry line setup. We also have a pretty big setup up here in the Northeast, which does include places of Ontario and Quebec. So if you live over there, I highly advise watching out for some severe weather. I'm going to live stream tomorrow. I don't know when, all right? But if you live here in the Northeast, if you live here in Quebec and Ontario, or if you live in any of these areas here in the plains, then feel free to tune into my live stream tomorrow, because I will be doing so. Now, let's take a look at the hail parameters here. Massive 5% chance for hail here in the Northeast. Massive 5% chance here in the Central Plains. That is indicated in brown. What's indicated in yellow is your 15% chance for hail. So whatever probability you have, that is your chance of seeing 1 inch size hail or larger. You also have a very expensive expansive, I should say, not expensive. Geez, it could be expensive, but expansive hatched risk here. That is a significant risk for severe weather, and that could indicate a 10% chance or greater of seeing 2 inch size hail or larger within a 25-mile radius. We also have our wind risk here, and we have our 5% indicated in brown, 15 in yellow. We have a 30% indicated in red. That is the reason why there is an enhanced risk for severe weather in Nebraska and northern Kansas. So if you live over in that general vicinity, you guys definitely have to watch out for it. And whatever probability you have, that is your chance of seeing 58-mile-per-hour wind gusts or greater within a 25-mile radius. You also have a hatched risk right here within the 30%. And so that is indicated that you could potentially see hurricane force winds or stronger within a 25-mile radius, and that would draw up to about 74-mile-per-hour winds or greater. We also have a tornado risk here, and pretty expansive tornado risk at that. We have a 2%, which is indicated in the green, 5% common occurrence is indicated in the brown. And so we have 2 areas of 5%, one in the Northeast, one in the Central Plains. The Northeast, I believe this will actually be fine. I know a lot of people don't really know a whole lot of Northeast setups, but what happens is along the Hudson River, there's a big valley here. And within that valley, if there's southerlies that can gather up moisture, actually bring up moisture return, moisture will basically be trapped within that Hudson River Valley. And if thunderstorms can form off of that front, which it's forecasted to do so, and I'll show you here in a bit, that could basically move across and basically create an energy pocket for thunderstorms to be able to form right before the mountains, and then once it gets over the mountains, basically all the wind shear that's channeled right within the valleys basically just shoot out, and you'll get your giant wind risk with a couple embedded tornadoes. So that's definitely something we're going to have to watch out for. But the plains, definitely a strong dry line setup with a lot of energy here. I would not be surprised if the stuff in the plains actually gets upgraded to a 10% chance for tornadoes, maybe even a 10% significant chance for tornadoes, but we're definitely going to have to watch out for that as well. All right, let's take a look at the simulated reflectivity for the Central Plains. I'm going to be using the NAM 3-kilometer model, so I'm not using the HRRR for the stuff in the Central Plains, mainly because the HRRR cannot correctly predict dry line setups. So I'm going to be using a model that does, and it just so happens to be the NAM 3-kilometer. So if you want to pay attention to the timings, feel free to do so. Look up to the top right part of your screen. So the simulated reflectivity here shows us that thunderstorms really start to kind of move on through here in Montana, Wyoming, down into Colorado. You even have some warm front action here in the Dakotas. But as that continues to progress, you can see these storms really start to fire off. They're pretty explosive too. And that goes all the way down into little places of Texas as well. You can see these storms around Amarillo as that continues to move on through. And then look at this massive, expansive, widespread risk for storms here heading into the overnight hours. It looks like, according to the NAM, that the southwestern edge of Kansas might actually be spared. But I saw in the HRRR that it also said that there could be some showers and thunderstorms down here. So we're definitely going to have to monitor it. As I said, I'll have more information for you all tomorrow. But as this heads into the evening, even into the overnight hours past midnight, this is when stuff really starts to kind of fire off as a more of a wind risk, and it could definitely cause some strong gusty winds and upwards of hurricane force. And so if you live within any of these areas here in northern Kansas or even central Kansas, down into southern and even southeastern parts of Nebraska, I would definitely watch out for this and be weather aware as this heads through into the overnight hours. Your dew points here for this event are pretty good. I'm not going to lie. Every area here, there's not really a whole lot of yellows and more or less a lot more oranges. And, as I said, within the yellows, this is indicated that there is 60-degree dew points and above, which is the type of moisture that you would want for severe weather. But there's a lot more oranges than yellows here, and that indicates that there's actually 70-degree dew points here rather than 60s, and that is really good for severe weather. So that's already adding up to be a concerning situation here. Your convective available potential energy, or your CAPE numbers. This is the measure of the warm air rising and the cold air sinking in the atmosphere, so the displacement between the two can indicate how much energy there is. You typically want 2,000 joules per kilogram of CAPE in order to consider strong severe storms, and that would be indicated in all of the areas here seen in yellow. There are areas that are in red, pink, well, not pink, purple, white, and even black here near Lubbock. And so there's definitely a lot of energy here, and upwards, even in Texas, almost 6,000 joules per kilogram CAPE. And that is just a lot of energy for these thunderstorms to go off of. And so, adding into more concern as this continues to move on through. Wind shear. Let's take a look at the lower level winds. This is, I did not update this correctly, so that is fun. But this right here is the 850 millibar wind. So 850 millibars. This is up 1 kilometer up in the sky, and you can already see there is a lot of southerly winds here, even southeasterlies that are starting to channel on through. This is your low-level jet that's carrying your moisture along this setup, and so right within here already, you already have some pretty good wind shear, even in upwards of about 30 knots, which is actually really good, a really good low-level jet for some severe weather. So something to keep in mind with that. Then we're also going to take a look at, we'll move on through here. We're going to take a look at our 500 millibar wind shear. This is up 6 kilometers up in the sky. So 6 kilometers above ground level. This is 500 millibar wind shear. And you can see how the winds have kind of veered off completely to the west. So these winds are coming from the west and they're going to the east. And this is favorable. You have some veering in the atmosphere, which tells me that you do have a tornadic setup here. And that is definitely something concerning as this continues to move on through. And we'll actually talk about that here with a couple of soundings. I know, right? Some people's favorite things to talk about. Perfect. So for most people here, they may look at this and be like, all right, Nate, that's it. You had me. I was cool with this weather stuff, but now since you showed me a bunch of squiggly lines and stuff like that, I mean, it looks like someone doodled. Let's just be honest here. Well, I guarantee you that this actually tells us what the environment is like within specific areas of the atmosphere. So what we are currently looking at is a sample from the environment in southwestern Nebraska, northwestern Kansas, and northeastern Colorado. This was taken at about 8 p.m. Central Daylight Time, 7 p.m. Mountain Daylight Time. What we're going to focus on first is this box up here to the top right. This right here is your hodograph, and your hodograph tells you your winds with height and how it changes direction. And so if you can basically imagine it as if you have a radar, more or less, if you have a radar and you're tracking a weather balloon, and your radar starts right here at the center of this little graph, you can see how the weather balloon travels up with height and how it moves to the north, and it moves down to the south and east, and it continues to move almost due east. Now, that's kind of an oversimplification. This is more or less that it tracks as if it's all in one spot. As it heads this way, it goes north, and then once it heads to this general vicinity, the winds are moving to the south and east at specific speeds, and then this is winds moving due east at say 60 knots and stuff like that. But this right here, this is the winds moving up with height, and this indicates you a bit more of your veering. So if you ever have your hodograph that curls off to the right like this at 0 to 3 kilometers, this entire red line right here, this is indicative for some tornadic potential. And so definitely something to be watching out for as this continues to unfold. And this does check out as a tornadic hodograph. Next, what we're going to want to look at is we're going to want to look at our right hand side here. Basically a bunch of these different squiggly lines over in that general vicinity. And what this tells us is this tells us our thermodynamics with height, or basically all of the temperatures, your CAPE, your dew points, all sorts of stuff like that, including lapse rates. I won't get into lapse rates here today, but that's what it tells us here on this side. So first things first, we have to identify what specifically we are looking at. So this green line right here, this is your dew point line. Your red line right here, this is your temperature line. This dotted line that goes up like this, that is a developing thunderstorm line. So that is the type of environment that a developing thunderstorm has to be in order for it to form and get into maturity, more or less. And so we call that a developing parcel line, but that's just something that we use to indicate what I'm about to talk about next, which is everything that is in between the red line. If the red line's on the left side and the dotted line is on the right side, that is indicated as CAPE. We talked about CAPE about a couple minutes ago, and how you need energy in order to form thunderstorms. And that actually indicates your energy right in between the two. So something to keep in mind with all of that. Now, the interesting thing about this is that we also have all sorts of different stuff around the sides of the sounding. So over here, you have wind barbs that go up the side of the SKU-T. And a lot of people be like, well, why is there a bunch of wind barbs on the side? Well, if you look on the left-hand side here, you can actually see these little red numbers, and this tells you your height in kilometers. So you have 15 kilometers above ground level, 12, 9 over here, 6, 3, 0, all sorts of stuff like that. So that's something pretty interesting. If you want to know how high it is up in the atmosphere, you can. You also have these white numbers on the left-hand side outside of the chart, and that is your numbers in millibars. So you have 850 millibars, you have 700 millibars, 500 millibars, so on and so forth as it heads higher and higher up into the atmosphere. So something pretty interesting to note with that. So this tells us that we have a lot of CAPE right in here. This also tells us that we don't have too much of a limiting factor. We do have a little bit of a warm nose here at 700 millibars. This could provide as a limiting factor to prevent thunderstorms from forming, or this could make supercell development explosive, and that could be concerning for some people who live in that general vicinity. So something to keep in mind with all of that. But just by me looking at this sounding, this definitely tells me that this is a bit more of a cyclic type mesocyclone. If stuff were to form based off of the hodograph, you have a lot of energy. It does seem to be a bit more high precipitation based, even though the precipitable water values are not too high. But just by me looking at the mid to upper level winds here at 3 to 6 kilometers, your ventilation isn't going to be all too insane. So you might have some residual rain that'll reside within, in front of the supercell. All right, we're going to take a look at another sounding here. This is Western Kansas. And by the way, all these soundings are from the NAM 3 kilometer, more or less. The HRRR with its wind profiles don't really differ all too much. And so I just decided to go with the NAM 3 kilometer based off of the convection and what all forms there. But your hodograph, same thing. It goes off to the right. It veers off to the right. And so you have a pretty good wind profile. Your ventilation even goes away from storm motion. So this is not exactly as much of a high precipitation based supercell. But this is definitely a more or less cyclic supercell in the upper levels, more or less. I think this is going to be high based, a bit more elevated. I'll talk about that here in a second. But your hodograph does indicate as a tornadic sounding, so that checks off. If we take a look at the SKU-T diagram, one thing that I do want to look out for is this thing, this little green line down here called the LCL. And your LCL stands for low cloud level or low condensation level. And this basically tells you how high up these clouds are going to be whenever it starts to rain. And so the lower you are to the ground, the higher the chance for tornadoes there is, mainly because there's a lot less distance for it to travel. You think of it that way, you know, how wall cloud's lower than most other clouds. Well, if that wall cloud is lower and lower to the ground, that tornado or that vortex doesn't have that much distance to travel down to the ground in order for it to become a tornado. So the closer you are to the ground with the lower condensation level, the better it is. An easy way to determine as to what the LCL is by looking at the dew point and looking at the temperature. And the closest it is to 100% humidity, which is basically when the temperature and the dew points are almost the same, then that is the highest chance for you to have your LCL be within your general vicinity. So that's just something really interesting that I wanted to make a note of, is that it is pretty high. It's about 1 kilometer up in the sky. I'll even draw a line from the 1 kilometer area right here. And yeah, it's even above 1 kilometer. So that's pretty elevated here in western Kansas, even southwestern Kansas. You have a lot of CAPE. You don't have a lot of limiting factors. So this might be more or less a hail risk rather than a tornado risk. All right, let's talk about northern Kansas here, southern Nebraska, kind of ish. Southern Nebraska is a little bit more veering, but this right here is your activity for northern Kansas. Your hodograph does veer off to the right. It actually curls and does a semicircle. So this actually tells me here that this is going to be kind of a mix between the long track and cyclic. Probably more cyclic more than anything. But this is a pretty good hodograph here for a tornadic rotation. So that does check off here. Now, if we take a look at the thermodynamic section of it, you do have CAPE right within this general area, but you do have a little bit of a warm nose that goes over the developing parcel line, and this actually could indicate that there is a limiting factor present in the atmosphere. And what that basically does is, if you think of it this way, I'm going to paraphrase and use an example here. If you can think about it as if it's a warm a pot with boiling water, and you have steam that's rising out of it. If you put a lid on the steam won't rise because it's hitting that lid. That lid is keeping all the steam and condensation in place. So that's basically what the limiting factor or the capping inversion does within an environment. And so if you want thunderstorms to form, that is definitely something that you don't want to see within your general area. But there are some instances where that capping inversion could be good for explosive thunderstorms, very dangerous thunderstorms that can produce some large hail and violent tornadoes and stuff like that. But you know, as of right now, it doesn't seem to be too likely until, you know, more or less Thursday. There is a chance for Wednesday here, but I took this sounding in the middle of the night, actually around 1 a.m. Central Daylight Time, and I don't really anticipate that to be all too much the case. I think within in front of the event that we see there in northern Kansas and southern Nebraska, we're going to have a very strong damaging wind threat with embedded circulations and stuff like that. So maybe some quick spin-ups within the line. All right, now that was a long talk about the plains there and what my 2 cents were. Let's talk about the mid-Atlantic to the northeast towards Quebec and Ontario. And just by 12 p.m. Eastern Daylight Time, there is already forecasted for thunderstorms to form across the general area. Now, most of you all in Quebec may be like, well, what the heck? Because these thunderstorms, you know, even though they're near Montreal and Quebec, and there's even some in Ontario here near Ottawa, you guys might be like, well, these storms have already passed us. What's the big issue? Well, later on in the day, you start to get some more thunderstorms that'll begin to form, and you can see the big line that moves on through, but then you'll have some residual cells that'll be basically firing off, and look at that. There's already some stuff around Montreal. So another line of convection will begin to form, and by 6 p.m., there will be some pretty good action that'll be moving on through here. New York will join the fray. DC and Baltimore will join the fray. Even areas near Boston will also join the fray. by give or take 6 p.m. Definitely something to watch out for. And then even Quebec and Ontario, you guys get your severe weather that move on through. So I will most likely be covering that live on my YouTube channel. If you have friends or family that want to watch me do it live, then feel free to tune in tomorrow. Your dew points here, as I said, you typically want 60-degree dew points and above, so anywhere within the yellow, more or less, is what we typically want to look out for. We do have some of these blues here, so it's not all too favorable, but you do have the areas that are in the yellow that are quite favorable for some severe weather. Even here, this is a bit out in front of the front, so I kind of took this dew point picture a little bit past most of the severe weather, but there is some good, decent dew points here for some severe weather across the board, and I would definitely want to watch it. Your CAPE, or convective available potential energy, isn't all too strong, but for the Northeast, typically you have wind shear that makes up for it. So if you have at least, let's say, 1,200 joules per kilogram in the Northeast, you will most certainly have enough for some severe weather as it moves on through. So that's just one of those things where, if you don't have any wind shear, you typically want 2,000 joules per kilogram CAPE. But if you have a lot of strong wind shear that backs it up, you don't really need a whole lot of energy to get, damaging winds, even the chance for tornadoes off of it. But some of these areas here in the dark green, that does indicate 1,000 joules per kilogram to 1,200 joules per kilogram. And once you start to get into the little bits and bobs of the yellows, you also get an upwards of 2,000 joules per kilogram as well. So that's definitely something to watch out for as this does continue to unfold in front of us. Now, here's what I was talking about with the wind shear. And this is the reason why I said the wind shear is going to make up for this event here. Even though there's not a lot of energy, there is some very strong winds here at the lower levels. We're looking at the low-level jet here, 850 millibars, which is about 1 kilometer above ground level. And you can see some very strong wind shear and upwards of 40 to even 50 knots here. And so that is some pretty strong wind shear across the board as this moves on through. And definitely something to consider as this moves on through, because this is at the lower levels. The upper level winds, well, actually, this is, I believe, the mid-level winds. Yes, it is the mid-level winds. Do show that it is even stronger above that. So some very strong damaging winds are possible with this as this moves on through. There even is a little bit of veering in the atmosphere. Not too much per se, but there is still the chance for tornadoes embedded within the line, especially along the northern Appalachians here, as well as into Canada. Definitely something to watch out for. All right, the last thing that we're going to talk about here is the borderline severe/tornado outbreak. We know it's most likely going to be a severe weather outbreak unless if it busts significantly. But the tornado outbreak is definitely possible because, well, I was looking at the models itself and it just looked too good to be true, more or less. And the Storm Prediction Center, in its outlook, it created a text specifically for the conditions that you could see. So widespread hail, widespread wind damage, and several tornadoes possible. Keyword, several tornadoes. So they're already assuming that there is going to be a tornado or two that's more possible than others, but several tornadoes as a whole possible. And that is concerning right within there. So a 1 out of 5 on the severe weather scale here for the marginal, a 2 out of 5 on the severe weather scale here for the slight, and a 3 out of 5 on the severe weather scale here for the enhanced. And so if you live within any of these areas, I highly advise you all to continue to monitor the weather as this continues to move on through. And by Thursday, May 27th, you should have a plan of action for whenever you are in a tornado warning. For instance, if you have a tornado shelter near you, I highly advise knowing where it is, and if you are in a tornado warning, you get near it. If you have a sturdy structure, get underground or get in your lowest, innermost part of your building, particularly a bathroom or a closet with no windows, so you can put as many walls between yourself and the tornado as possible. That's the type of plans that you're going to want to make in order to try and protect yourself. So that's definitely something that we're going to want to watch out for. Now, if we take a look at the probability outlook here, 5% chance for severe weather in brown, 15 in yellow, 30 in red. That's, just your chance for some severe weather. You also have your significant risk for severe weather in this dotted line. And so that is significant for any of the parameters, whether it's wind, hail, or tornadoes. I potentially think that it is, what they're issuing for here is large hail in both of these significant risks. But I also could think that there could even be a significant risk for tornadoes right within here. And as I said, I would not be surprised if they issue a 4 out of 5 in the severe weather scale. And so this is definitely a concerning event here that we will have to continue to monitor as this gets closer. Now, if we take a look at the timings here, we can see that we have a pretty low resolution, pretty low resolution, simulated reflectivity, and that's because we don't exactly have a model that goes out that far quite yet. We have this medium range model that gives us low resolution for the most part, but I'd have to wait later on tonight in order to actually see the high resolution models, and even tomorrow. So we'll have some better data for you all in tomorrow morning's video. If you want to stay tuned to that, please be sure to do so. Turn on notifications. I will be sure to get you that video. But what we will have to settle for is the North American model. And the North American model here tells us basically, did I not set the timings correctly? I did not set the timings correctly. This is absolutely wonderful. Well, there we go. We'll just fix that. But this is the early afternoon hours here. Showers and thunderstorms across northern Missouri into Iowa, down into Kansas and Oklahoma. As this continues to head into the late afternoon, early evening hours, storms really start to pick off, and by 7 o'clock, you can see a lot of these storms really start to kick off. Even here in southern Kansas, northern Oklahoma, that's honestly the area that I am watching the most, in my honest opinion. You can even see this is a low resolution model, but it's already starting to form a little bit of a hook here. That is not good. So, big time supercells that could be forming off of this with large hail, damaging winds, and even tornadoes, some could which be even significant. So, we're really going to have to watch out for this as this continues to move on through over time. And as this continues to head overnight, past midnight, you can definitely see this start to consolidate more into a line, but you might even see some embedded rotations within that as well. All right, let's take a look at the dew points here. It's very similar to what we were talking about in the plains on Wednesday. And so you can see the yellows are 60-degree dew points here for the most part, but then you have a lot more oranges than yellows. And this indicates that there are 70-degree dew points within this area. Very moist for thunderstorms to be able to suck in all of that energy and be able to gather up as much as possible to create storms. And so we have some pretty good dew points here. As I said, 60-degree dew points and above is what you want to see for severe weather. And that is exactly what we have here. Our convective available potential energy, as I said, warm air rising, cold air sinking. The displacement between the two can indicate how much energy there is in the atmosphere for thunderstorms to form or sustain. And you typically want over 2,000 joules per kilogram in order to get thunderstorms, strong thunderstorms more or less. And anywhere in the yellow, that's 2,000 joules per kilogram. You have stuff in the red, stuff in the purple, even stuff in the white that indicate about 5,000 joules per kilogram CAPE. And so we have quite a few areas that have some significant amounts of energy. And this is definitely something that we're going to have to watch out for from a thermodynamic perspective. Excuse me. Now we're going to take a look at the wind shear here. This is the lower level winds. Once again, I did not get the dew point correctly set up, or, well, the slideshow set up. And so, oh well, we'll figure it out. But this is the 850 millibar winds, or the 1 kilometer above ground level winds here in the Central Plains. You can see you have a lot of southerlies, even southwesterlies here in Oklahoma and even Missouri. And so you have some pretty strong wind shear here from 20 knots all the way up to 30 knots in some of these kind of goldish colors. Some of the reds and even the browns up towards the north, towards towards Iowa. That's in towards the 50 knot general vicinity. So you might see a lot more of a damaging wind threat there, except for maybe Quad Cities where there could be something of tornadic nature up there. So, but it is possible. It definitely is possible. If we switch over to the, I believe this is the upper level winds. Yep, this is a 500 millibar jet. This is 6 kilometers above ground level, and you can see there is definitely some veering of the winds. You can see how the winds change in direction. I drew those arrows to show you what the winds were at the lower levels. Now we're looking at the upper levels, and they do veer off to the right. So this is a good indication that there could be the chance for some supercells that could be tornadic, and we are going to have to watch out for this, especially here in Missouri, Kansas, Oklahoma, and extreme northwestern parts of Arkansas. That is the area to watch here on Thursday. All right, last thing here, this is the end of the video, but I did want to shout out to all of my sponsors here, the channel members here. If you want to become a channel member, link is in the description down below, but all the people here you see in front of me, this actually are the people that have been supporting my channel for quite some time, so I want to say thank you all for doing that. I really do appreciate that. If you guys did enjoy the video, please be sure to like it, subscribe if you're new, turn on notifications, share this with friends and family and on social media. Also follow me on social media and join my Discord server down below. That's going to be it for me. My name is Nate. I also go by HockeyBoy8. I'll catch you guys in the next video. Peace out.